today we're going to continue with ellipses, but it's going to be going the other direction. So instead of us starting with an equation and then drawing it or doing something with it, we're going to work backwards to figure out what is the equation. Okay, so there are a couple different ways that we're going to be given problems. So the first one is they're just going to draw a picture and then we're going to write the equation for the ellipse. Okay, and then the other part, which is sort of like the little puzzle I was telling you about, is they're going to give us some characteristics of the ellipse, and from those characteristics we should be able to figure out all the things we need to be able to write the equation. Okay, which just means that we have to, it's not hard per se, like that's why I sort of struggled with it. It's not hard, it's just you have to think about it a little bit more, right? And so you just have to remember your characteristics, remember the pieces that you're given, and keep going until you have everything you need. Okay, so everything that we need to write an equation of an ellipse is we need the center, and then we need the where's our equation? Oh, here. We need the center, so we need h and k, and then we need our values for a and b, right? And we need to know, does it go longer along the x-axis, horizontal, or does it go longer along the y-axis, vertical? And once we know those four things, I guess, so the center, a, b, and which direction it goes. Once we know those four things, we can write the equation every time. Okay, so we have to be able to get those things. So just reviewing our equations, I'm just going to rewrite them so that we have them. Okay, x minus h squared, y minus k squared equals 1. Like all of that stuff across the top stays the same for both of our ellipses. X minus h squared, y minus k squared equals 1. Okay. And all of that comes from the center. And then down on the bottom, we have a squared and b squared. Okay, so if our ellipse is horizontal, that's going to go longer along the x-axis. So our bigger value a is going to go with our x term. So if we have a big number under x, it's horizontal, and then b is our smaller number. And then if it's vertical, it goes longer along the y-axis, so our big number will be under the y and smaller number under x. Okay, so remember the distance between our vertices is our major axis. The major axis is 2a. Okay, so the distance from the center to one of our vertices is only going to be half of that, right? Jamarin, you good? Okay, so all the way from vertex to vertex is 2a. But if we start at the center and we go to one of those vertices, that's going to be just a by itself, right? So we actually have two different ways you could do that. If they give you the major axis, you're just going to cut that length in half, right? But if they give you, or we already know the center and we know one of the endpoints, then we can just find out how far between them, and that'll be our a value, okay? Same thing for b. The center to the co-vertice is b, or they could give us the minor axis, which is 2b. And then c is our center to the foci. Okay, so c squared, a squared minus b squared for that. And then again, the distance between the two foci, there's not really a name for it, but if you have the two foci and you found the distance between them, that would be 2c, right? Or how far that would be. Okay. All right, so the graph is pretty straightforward as long as you can see where the center is. Okay, is there anybody who's like, I really have a hard time telling where the center is on this shape? Because I will come to you and I will help you with that. Okay, All right, so everybody can find the center okay on their own? All right, so this looks like it's the top, the bottom right here, and then along here. So this point right here is going to be our center, which is going to be, so remember, every time you count, I don't know, I had lots of questions on this. When you're counting or naming your ordered pairs, we always start from the origin, right? So find wherever the center is and then go back to the origin and count over and up or whatever you have to do. So this is going to be -1, +2 for our center. Okay, the vertices are going to be the ends out here of our major axis. So this is going to be 1, 2, 3, 4, 5, 6, comma 2. And 1, 2, 3, 4, 5, 6, 7, 8. Is that right? -8, 2. Y'all agree with that? Okay, so before we do the covertices, I just want to show you, because on the next page, you're not going to have this picture, and they're just going to give you these values for the vertices. Okay, so notice in these two ordered pairs, do you see how they share a number? Okay, I don't care about the shared number, okay, when I'm talking about how far between them. So I'm going to ignore the 2's, and I want to know how far from 6 to -8. So if you think, like on a number line, how far from +6 to -8, you're going to have to cross over 0, right? One's positive, one's negative, you have to cross over 0. So from 6 to 0 is 6 spaces, and then from 0 to -8 is 8 more spaces. So we add those two numbers together, and we get a total of 14. Okay, so this tells us here that 2a, the length from between our two vertices, is going to be 14. Or half of that would be 7, and that would be our a value. Does that make sense? So if both of the numbers are negative, okay, like let's say I wanted to know how far from -15 to -3, I don't have to cross over 0, right? So I'm just going to subtract how far between 3 and 15. I don't care about the negatives. From 3 to 15 is 12 spaces, right? If they both have the same sign, you just subtract the numbers. If you have one positive and one negative, then you're going to add them because I got to jump over 0. Okay. All right. The other way that we could tell that A was 7 on our graph is we could literally just count, right? Like from here to from the center to the edge, 1, 2, 3, 4, 5, 6, 7. Like this is our A value, right? Okay. Did you already fill in the covertices? Y'all are already ahead of me. Okay. Covertices are what? -1, -1, 5? Yeah. And -1, -1? Yes. Okay. Okay. And looking at my picture, this value of B is going to be 3. Like I can count that. Okay. But if I looked here, again, I don't care about the number they have in common. They both share this -1. But how far from 5 to -1? That's 6. So 2B is going to be 6, which means B is 3. Right? Super easy with the graph. We still got to be able to do it with the points. Okay, so this, we know that A is 7, we know that B is 3, and we know our center. So we can take those 3 things and write our equation. The last thing we need to know is which direction is this going? Does it go longer along the x-axis or longer on the y-axis? Like you can see it in the picture, right? It looks like Stewie's head, right? It goes sideways. Okay, so the bigger number, a squared, is going to go under our x, right? So we're going to have x plus 1 or minus 1 when we put it into our equation with our center. Does it stay the same or change? Change. Plus x plus 1 squared, y minus 2 squared equals 1. And then a squared is going to be 49. And we said that needs to go under the x. And 3 squared is 9. Okay. And then the last step for this one would be to figure out the foci. So in order to do the foci, we need to know what c is. C squared is a squared minus b squared. And we just said a squared was 49 and b was 9. So we'll do a square root of that. So the square root of 40 is 6.3. So if I were to count 6.3 from the center, we're going to go along the major axis towards our vertices. So 1, 2, 3, 4, 5, 6, and a little bit. Might put a line there instead of a dot. So that's just right before that last vertice. So instead of going all the way to 6, we're going to go to 5 point. Our decimal was 0.3. So we're going to be at 5.3 comma 2. And then the other one right in front of negative 8 would be negative 7.3. Okay. All right, so what I'd like to do on number 2 is just write the equation. Like just from the graph. All I need to write down is we need the center. I'm just going to write over here. We need the center, we need A, and we need B. And then from that, we can write the equation. Okay. And for these graphs, all of your centers should be nice whole numbers. Like none of them are going to be halves or 0.7s or anything weird like that. All right, so this center is going to be at positive 1, 2, 3, down 2, positive 3, negative 2. And where do we find the A value? A goes from the center to one vertex. So this line right here is going to be A. So how many boxes is that? 5. And then our B value is going this way. That's 2. 5 and 2. Okay, and so from that, now we can write our equation. The stuff that takes longer is filling in all the points and doing all the other things, okay? So for our equation, our center is positive 3, so that's going to be x minus 3. Opposite of minus 2 is plus 2. And before we write down our last two numbers, 1, we got to remember to square them, right? We're not going to put 5 and 2. We're going to put 25 and 4. But which direction is this ellipse going? It's going vertically, so that means our bigger number, 25, needs to be with the y-axis. And then the 4 will go there. Okay, so I'm not going to worry about writing down all the other things right now. Y'all can do that another time. Okay, so let's look at the characteristics. Without a graph, we got to figure out things. So they're going to give us 2 pieces of information. And from those 2 pieces of information, we should be able to figure out the equation. Okay, again, we need the center, we need A, and we need B. Okay, so first of all, we're going to find the center, H comma K, using the midpoint formula. So the center is in the middle between the two vertices. Or the center is in the middle between the two covertices. Or the center is in the middle between the two foci. So whatever set of points you're given, the center is in the middle. Okay, so the midpoint formula is this one that says you're going to add your two values together and divide by 2. It's just an average. When you're trying to find the middle of something, you add the values and divide by 2. So we'll do that for the x's, and we can do that for the y's. Technically, we only have to do 1 because remember how all of our points share one number? Right? Like they both have the same y value. They're both 2. Well, if you added 2 plus 2, and divide by 2, you're going to get back to what you started with. Okay, so whatever number they share, you don't need to worry about doing that with just the other number. Okay, so that's going to give us the center. And then we're going to use the vertices to find A. From the center to A is the center to a vertex. Okay, how far from center to the vertex? That'll give you A. B is going to be center to the co-vertex. And then if you are given C, like you're going to have to work backwards to find one of these. So our formula is right here for if we're given the foci, we're going to have to figure out what C is, and then we can go back and just, I guess we could put C is a center to one of the focus points if you needed that. Okay, so again, we need center, A, B, and the direction, right? Determine the direction of our ellipse before we write our equation. Okay, and the only thing that's going to change is where A squared and B squared go. Okay, so number 4. We are given the vertices at 5, -2, and -19, 2. Do you see the number that's different there? They both share the -2. So I'm going to look at the 5 and the -19. Okay, so the center is going to be halfway between 5 and -19. So 5 plus -19 is -14. Half of -14 is -7, which is going to put our center at -7, comma, the number that they share, -2. Okay. The next thing they give us is the length of the minor axis. If they give us the minor axis, which value is that? Minor axis, is that 2A or 2B? B. 2B. So if 10 is 2 times B, then B is going to be 5. So we have B is 5. We have our center at -7, -2. So the only thing we need now is A, right? And then we'll have all the things we need. So A, right here, is our center to our vertex. So if we're trying to find A is the center to the vertex. So the center was -7, -2, and the vertex was, well, we just need to pick one, because there are 2 of them. Pick one. Which one makes you happy? 5, -2, or -19? Which one? The first one? Great. 5, -2. It does not really matter. We'll get the same answer. Okay, so we need to know how far between those. So which number should we be looking at? Not the -2's, because they're both the same number. So how far from -7 to +5? If you think about that on a number line, how far from -7 to +5? 12? A is 12. Does anybody want the mathematical way to do that instead of just like common sensing it with your brain? Do you need to be able to type it into your calculator? Would that make you happy? If it is, okay, distance between 2 points is just subtract the two numbers and then make it positive. So whatever your two numbers are, make sure you have a subtraction sign between them and then make it positive. Okay? Yeah, that's fine too. Okay, so now we have all of our things. The last thing we need is our direction. Okay, so on this, the direction of our ellipse is determined by a couple things, right? The vertices are the ends of that longer part, right? Whichever way they go, the vertices are at the ends of it. Are you all with me? This is like the most important part right here. Okay, so the vertices are the ends of our longer part. Okay, so the direction is going to be determined by whichever number changes. Okay, so on our vertices, okay, which values change? The x's change. Okay, so since the x's change, that means our ellipse is going to be horizontal, because those x values determine how far out we go from left to right. Okay, now if they give us the co-vertices determine the little part, right? So whichever value is changing here on our co-vertices, that's going to give us the little part, so the other way is going to be the longer direction. Does that make sense? So you just got to be careful on what value they give you. Okay, so let's write our equation for this one. So we have our center at -7, -2. So that'll be x plus 7 squared, y plus 2 squared, always equal to 1. And then on the bottom, we're going to have a squared and b squared. So that'll be 25 and 144. But our x's change, so we want our bigger number to be under the x. So this is going to get the 144, and this one's going to get the 25. Okay, so it's sort of, and again, it sort of seems a lot until you sort of start wrapping your brain around what things you're looking for, and then it's gonna go faster as you get more comfortable with that. Okay, let's look at number 7. All right, 7, they give us vertices and they give us co-vertices. Okay, so the center is in the middle between those. Okay, and I'm going to give you a hint. Okay, well, how do I know this without doing any work? How do I know that the center is 0, -3? How do I know that? Where's the 0 come from? The vertices share the number 0 in the x spot, which means the center has to have a 0 in the x value. And then the co-vertices share the -3 on our y value, so that means that has to be our center. Okay? Could you do it the other way? Could you find the midpoint between any one of those? Absolutely. This is just a little bit faster. Okay? Our direction, let's go ahead and do the direction now so we don't forget about it later. Okay? So on our directions, if we look at our vertices, the vertices are going to give us the direction of our ellipse. Okay? If we have that. So which value changes on our vertices? X or Y? Which numbers are changing? Y's change, which means this is going to go left to right. Okay? On our co-vertices, if all they gave us were the co-vertices, the x's change. for the co-vertices, which means the y's would change for the vertices. We'll go the other direction. All right, let's see. Now we need A. A is the center to a vertex. So center to one of our vertices. So 0, -3 to 0, 12? Sure. Doesn't matter which one. So how far from 0, -3 to 0, 12? I don't care about that. From -3 to 12, A is going to be 15. Okay, and if you wanted to do the math, again, you could do -3 take away 12, and then just drop off the negative sign if you needed to type it into your calculator. B is our center to the co-vertices, which is 0, -3 to 4, -3. I don't care about the -3s, so that's 4. And now I have A and B and our center, and we know which direction it goes, so we can write our equation. Yeah? So if the point is 0, you don't need to write x minus 0, so we're just going to have x squared over something, y plus 3 squared. And we said, oh, I drew my arrow the wrong way. You said the y's changed. Nobody stopped me on that. Y's changed, so this is gonna go up and down, right? With our y's. I just drew my line sideways like I've been doing for everything else. So my y's changed, which means the bigger number has to be under the y. So 15 squared is 225. And 4 squared is 16. We'll get there. Let's talk about foci for just a second. All right, so on number 8, we're not gonna write like the full equation anymore. We're just gonna like find our pieces and then we'll go on to the next one, okay? So on number 8, we have vertices and we have foci. So again, we can still find the center. Obviously our center is gonna start with 5, comma something, because these all have 5s. So I need halfway between any of these. So halfway between 11 and -15. 11 plus -15 is -4. -4 divided by 2 is -2, which would be the same as that. All right, so we have the center. Now we need A and B. Which one of these could give us one of those letters? Vertices, foci, A or B? Vertices gives us A. Okay, so we're going to use A from the center to one of our vertices. So pick one. I'll pick the -15 this time. How far from 5, -2 to 5, -15? Again, I don't care about the 5s, so I need how far from -2 to -15? 13, because they're both negative, so just subtract the numbers. Foci give us what letter? C. So we're going to have to find C, and then we'll work backwards to find B. So C, center to a foci, is going to be our C value. So -2 was our center. Pick one of these numbers for our foci. Yeah, again, I don't care about the 5s. That's 12. Okay, so this is not going to go in my equation, but I need it. Okay, so now to find b, we're going to do c squared equals a squared minus b squared. So we just got to do a little bit of algebra because we already know a and c, so we can work backwards to find b. So c squared is going to be 144. A squared is 169. Take away b squared. Okay? The rule of subtraction is you subtract the two numbers, right? To tell, like, 169 take away what number is 144 is the same as 169 take away 144, right? So that's going to be 25. So b's 5. Okay, and then we have everything to write our equation. Okay, let me share with you just real quick. I'm not going to do anything on this problem on number 9 other than look at this. Do you see this sort of radical notation right here? Okay, this, as ugly as it looks, tells us a lot. Okay, what this tells us is that our center is at 4, 3. Okay, because the foci go off of that center and they're going to add or subtract whatever to each side of that. So these two numbers, the number in the front without the square root and the number at the back without the square root, wherever that is going to tell you the center. You could still find it by doing halfway between your vertices if you wanted, but it's like already right there in front of you. Okay, the other thing this tells you is that C is the square root of 21. That number that you're adding or subtracting to the center value is going to be C. Which means if C is the square root of 21, then C squared, if I square both sides of this, when you square a square root, they cancel out, and it would just leave us C squared would be 21. And then we could do the things that we needed to from that. Okay? So as much as that sort of looks scary, it actually like tells us all the information we need to know, and then we can just move on faster. Okay, you said 10 was scary? Was 10 scary because it has the square root thing in it? Yes. Yeah? Okay. So not really a big deal. Well, let's do one. Let's do 10. We're not going to do the whole problem. Can you tell me on 10 what is the center? What is C squared? Oh, well, maybe we need to do, let's do that part together. Yeah. Let's do C, and then we'll find A and B. All right, so the center in 2 seconds. Negative 3, 6 from our foci. And the rest of this, the 2 square root of 10, is C. So do y'all remember how to square that? So when you square both sides, when you square something that has a whole number and a radical, you're just going to do both of them squared. So we'll do 2 squared and square root of 10 squared. It's easier in your head. 2 squared is 4. The square root of 10 squared is just 10. So 4 times 10 is 40. So you square the number in front and you multiply it by what's underneath, essentially, is what you're doing. Okay, so C is going to be 40. We could do all the other things. Can you tell me which direction this one is going to go? So the co-vertices, which letters change for the co-vertices? The X's are changing.
So it's vertical.
So if the co-vertices go this way, look at my hands. The co-vertices go this way, that's the narrow part. That means the long part is going to go vertically. So this is going to be an up and down bigger number under the Y. Yeah. All right. Are you okay with finding B and A on this one, or do you want me to go through that since we only did one? Like that. Do you want me to keep going on this one?
Yes.
Yeah? Okay. So we have the center. We have C. Oh wait, this is C squared, not C. C squared. Sorry. C squared is 40. All right, so let's see. We need either A or B. So which one of these things, well, covertices, we already used the foci. Covertices gives us which letter? Covertice is A or B? B. So I need the center to one of the covertices. So the center is -3, 6. One of our endpoints of our covertice is 0, 6. So from -3 to 0 is just 3 spaces. So now I have the center and B. Now we need A. So to find A, because they don't tell us anything about our vertices, we're going to have to use our foci. So C squared equals A squared minus B squared. And we said C squared was 40. We don't know A squared, and B squared is going to be 3 times 3, which is 9. So what number, when you take away 9, leaves you with 40? $49. So A is going to be 7. Or you can plus 9 to both sides, however you want to do that. Yep. All right. So 12 and 13, they give us the length of the major or the minor axis. Okay, do you remember which one is which? Which letter? Minor is going to equal 2B. So B is going to be 4. Major axis is 2A. So 2 times what makes 18? So A will be 9. And then you could do your other stuff, right? Okay, so the last one, down at the bottom, we have the, they give us the eccentricity, again, which is how like round or how watermelon-y our ellipse is. So does anybody remember the formula for eccentricity? What's the ratio? It's a good thing we have this packet that's like stapled together and we can just look back to where it says, oh, look, right there, eccentricity, C over A. Okay, now here's the deal. This C over A is a ratio, okay? It may not always be in lowest terms, okay? Well, they're going to give it to us in lowest terms, but we might need to expand that. So like if we said, I'm just going to give you an example. Let's say that our eccentricity was 12 over 5, right? Just going to make it up, 12 over 5. And then the length of, let's say that A was 10. Okay, like we looked at they gave us the vertices, we figured out that A was 10. So when I look at this ratio, this is C, 12 is C, and 5 is A, right? But according to my vertices, A is supposed to be 10. So what should I do to this 12 over 5 to make A 10 and not 5? Times it by 2 so that I'll have 10 and 24, right? So C is actually 24 and A is actually 10. Does that make sense? So when you're looking at the eccentricity, sometimes it's just already simplified. Like these examples that they have for us here, they're already like correct. But it's not always that way, which I don't like about these two examples that they have here. I wish they had done one that was different. Okay, So, let's see. All right, so this is our ratio of C over A. So we just got to check our vertices and we got to figure out if that's going to match with one of those. Okay, so how far from 7 to negative 7? 14. So that's 2A, right? So 2A is 14. So A is going to be 7, which matches with what we got here, right? And then the center is going to be in the middle between those 2 points, which is going to be 0, right? Halfway between 7 and negative 7 will be 0, negative 2. We know that A is 7. We know that C is the square root of 33, and we could figure out what B is. Da-da-da-da-da. Do you want me to finish that? Okay. Okay. Yeah. So again, it's not like, I mean, to be honest, this is probably the most time-consuming part of what we've done, right? Like you just, what are we given? What does it tell us? What do we need to find? How are we going to do that? Like you just have to sort of take all these little tiny pieces and put them together.